Welcome to Brain Vision.
Alrighty, so this chapter is about partial derivatives. This section is about using partial derivatives to make approximations. For this problem here, where we have the body mass of a person, which is B, we can sort that out from their mass in kilograms and their height. And that's going to be equal to their mass divided by their height squared. Okay, and so we're going to use a linear approximation, and the formula for that is the approximation at xy, or in this case, mh, I suppose, is going to be equal to our function b at some point. Let's call it m naught h naught. Plus b, the partial derivative with respect to m, at our same point, m naught h naught, which kind of looks like moho. That's fun. Times m minus m naught plus the same function with the partial derivative with respect to h at the same point, moho, times h minus h naught. Okay, so that's what we're working with. So let's just sort that out. So we're given that our m naught h naught are going to be equal to 23 kilograms and 1.1 meters. Okay, so let's just start by calculating this first piece of our puzzle. All right, so b at 23 and 1.1 is simply equal to the formula as it is, 23 divided by 1.1 squared, and that ends up being roughly equal to 19. Okay, so now we're going to take the partial derivative with respect to m, which is easy. Now this is just going to be equal to 1 over h squared. So if we find this at the same point, that is simply equal to 1 over 1.1 squared, which is roughly equal to 0.826. All right, so now we're going to get the partial derivative with respect to h, which is a little bit sneakier, but it ends up being equal to negative 2m over h cubed. Okay, so we want to calculate this with respect b with respect to h at 23 and 1.1. So that's going to be negative 2 times 23 over 1.1 cubed, and this is roughly negative 34.56. So now we just have to plug it in to that formula, our L from above. Okay, so that means L, our linearization at m and h, is going to be equal to 19 plus 0.826 times m minus 23 minus 34.56 times h minus 1.1. So we do all the multiplying and then adding and subtracting like terms, and we end up with 0.826m minus 34.56h plus 38. Okay, so this was part A, but our job is not quite done yet. We have a part B. Okay, so part B says if the mass increases by 1, so we want an m plus 1, and a height is increasing by 3 centimeters. What does that mean? Okay, so we're going to use our linear approximation. And that linear approximation had occurred at, remember, was at point 23 and 1.1. Okay, so if we add these values, we want to now approximate our point at 24 and 1.13. So we're just going to plug that into our linear approximation that we have here, right? So we would say, if we approximate at 24 and 1.13, that's going to be roughly equal to 0.826 times 24 minus 34.56 times 1.13 plus 38. And the calculator says that is equal to 18.77. Now if we compare it to the actual function, b of m over h squared, so that would give us 24 over 1.13 squared. That is roughly 18.80. Okay, so that's a pretty good approximation. So the linear approximation is 18.77. The actual formula gives us 18.8.